Pre-Calculus. Today we're going to start section 5.3 in your textbook. It's on trig functions on the unit circle. I ask you through Remind to come back to school and pick up a copy of the unit circle, a paper copy of the unit circle, as well as the trig table. They are in the front office, and it would be to your advantage to come by school and pick one of each of those up. That way you can put them in your notebook and you can use those as reference sheets as well. So what I'm going to do today is go over the unit circle with you. The first learning target is I can label all the parts of a unit circle. By parts, I'm referring to degrees, radians, and then of course the ordered pairs on the circle. When we do that, then we'll come back and we'll talk about the trig functions on the unit circle. But I did want you to write the title down first. Okay, so the second thing I want you to do is, and again, this will be easier when you have your own paper copy, but your job is to think about the unit circle in these terms. So I'm going to grab my highlighter, and I'm first just going to highlight the X and Y axis so we can kind of keep those separated from all the other lines that are drawn on this picture, because there's a lot going on here. And we know from algebra that this is your x-axis, of course, and this is your y-axis. We're going to tie in some things that we've already learned in trig in this the last couple of weeks from section 1 and 2. Unit circle is known as the unit circle because all the radii or radius is equal to 1. So every single line segment you see on this picture, excluding the x and y axis, well actually including those as well, every single one of these are radius or radii because they start at the origin and then they touch a point on the circle. Okay, and so all those radii are 1 unit long. It's 1 unit long. Each of these points, the distance from the center, the origin, to these locations that I'm putting in red are 1 unit. Next, recall from the past we've talked about initial side of an angle and the terminal side of an angle. The initial side is always going to be, like in standard position, it's always on top of the x-axis. When I swing the initial side open, wherever the terminal side lands is going to create an angle. So the first space you see here is when I do not open the initial side at all. So that is going to be 0 degrees. 0 degrees. The radians for that is the same thing as 0 pi. 0 degrees and 0 pi are the exact same angles. Okay, so I'm going to do red for degrees, blue for radians. I need you to make sure that when you are copying this down that you have the degrees in the first blank in each of these, okay? Alright, that way we can all be consistent. So for the next one, moving up, we're starting here, we're moving counterclockwise around the circle. The next location is here. The angle that's created from the initial side to the terminal side is a 30-degree angle. So this is 30 degrees right in here. Okay, at 30 degrees, you're now going to have to convert that to radians. You've been taught in the past how to do that. I'm just reminding you of this. But I told my in-class people, in-person people, that honestly it's better. I mean, it's great to know this, and that way you can double check yourself. You can multiply by pi over 180, and you can use your calculator quickly and figure out what the radians are. But when we do timed quizzes on these, and I have been known to give 3 or 4 quizzes on the same topic, this topic, it's to your advantage to not waste your time, like spend your time doing this because you're going to run out of time on a quiz, but instead make sure that you memorize that 0 degrees is 0 pi and 30 degrees is pi over 6 and so forth. This, of course, you can always fall back on to make sure you're okay. But there's tons of patterns in this unit circle. There's all kinds of ways to teach this. There's all kinds of little mnemonic devices on YouTube. You can also use those resources to help you. So whatever works that you memorize these and you're not just copying off a reference sheet, because in the end you're not learning that and it's not going to help you on the application part either. So memorize the degrees, the radians, and the ordered pairs. Okay, we're going to move to the next slot up here. That would be as if I had you start at the x-axis and create an angle that I've highlighted in green. That angle is 45 degrees. Okay, so 45 degrees will go here. And the radian measure for that, 45 degrees times pi over 180, is pi over 4. Alright, next, if I were to take the initial side, swing it open, and then my terminal side lands there, that angle in purple is a 60-degree angle, 60 degrees. So this, in this position, you would write 60 degrees. For the radian measure, it's the same thing as pi over 3. And one more here, and then I'll share a little pattern with you. When I swing the initial side open to the top for the y-axis, that creates a right angle, and that is 90 degrees. And we're going to put 90 degrees here, and then we're going to do a radian measure beside of it. What's equal to 90 degrees is pi over 2. So we're going to write that here. Alright, so these angles always go, once you learn the first quadrant, the rest of it will fall into place. So this is the most important quadrant to start memorizing. Once you got this down pat, the rest, again, will fall into place. They're so much easier. Here's the pattern. From 0 degrees, the first tick mark is 30. So you'll add 30 degrees, and then notice the difference between this one and this one's only 15. And then from 45 to 60 is also 15, and then from 60 to 90 is 30. So you will add 30, add 15, add 15, add 30. From 0 degrees, to get your degree measurements around the first quadrant, you will add 30, add 15, add 15, add 30. Moving right around the circle now. When I'm on the initial side and I follow my pin and I swing it open and my terminal side lands here in the second quadrant, I have now created a 120 degree angle. 120 degrees. The radian measure that matches that is 2 pi over 3. 2 pi over 3. Add 30, add 15, add 15, add 30, add 30. Next should be add 15. And so your next angle over here in the middle of quadrant 2 is 120 plus 15, which is 135 degrees. As a radian measure, that is 3 pi over 4. Add 30, add 15, add 15 more. 135 plus 15 is 150 degrees. That'll be your next angle. In radian mode, 150 times pi over 180, you can use your calculator to convert that if you need to. That's going to be 5 pi over 6. Add 30, add 15, add 15, add 30 more. 150 plus 30 is 180 degrees. This is a half of a circle. Radian measure for 180 degrees is just pi. Next, we're going to add 30 to 180 to get the angle right below the x-axis in the third quadrant. That's called 210 degrees. Again, imagine me starting on the initial side and I've swung open the angle and I've landed right there. That's 210 degree angle. In radian mode, that's going to be 7 pi divided by 6. 7 pi divided by 6. Next, I've taken 180, I've added 30, now I add 15. Next pattern is 15. 210 plus 15 is 225 degrees. At 225 degrees, your radian measure is going to be 5 pi over 4. Next, 225 plus 15 more is going to be 240 degrees. 240 degrees for this angle right here, and the radian measure for that is 4 pi over 3. Okay, next you're going to take 240 and add 30 to it, and you're going to get 270 degrees at the bottom. In radian mode, that is 3 pi over 2. 3 pi over 2. At 240, I've added 30 and I've gotten 270. I now add 30 more to get the next angle, and now we're in the fourth quadrant, notice. But the angle is 300 degrees. So making sure you're still understanding, if I start on top of the x-axis and I swing this angle open all the way and land right there at the terminal side, that's 300 degrees. 300 degrees is the same thing as 5 pi over 3 in radian mode. Okay, so I've added 30. Now it's not time for me to add 15. Well, 300 plus 15 is a 315 degree angle. Radian mode, 7 pi divided by 4. Next, add 15 to 315, you get 330. 330 degrees in radian mode. Let's see. 11 pi over 6 is going to be that radian answer. And then you notice that there is two blanks right below 0 degrees on your unit circle, and that's as if I started on the initial side and I wrapped all the way around the circle and I landed back on top of the initial side. That's a complete rotation or revolution around the circle. That's 360 degrees, and we know from the past that that means there's 2 pi radians. So this again is called the unit circle. Very, very important concept for pre-calculus trigonometry. No matter what field you're going into, everyone has to take college algebra, and this is a part of that. Trig is part of college algebra. And then there's also other fields, math, science fields, computer fields, that will require you to take, could require you to take a trig class, and then of course you're going to use this again. So the unit circle, extremely important. We're going to be using this periodically throughout the rest of this school year in this class. Please remember that the radius and the radii, all the radii in this circle, and the unit circle is 1. And the learning target, the first one, is I can label all the parts, and the parts are degrees and radians and ordered pairs. So we've got 2/3 of that done right now. We've labeled the degrees, we've labeled the radians, and now we're going to look for ordered pairs. So we'll go in here and erase this stuff and try to help you see how to find the x and y coordinates. Okay, all right, here we go. For the first one, At 0 degrees and at 0 pi, the ordered pair for this, I'll do these in green, the ordered pair for this is going to be the distance from the center of the circle out to this location here in green. Well, since in a unit circle the radius is 1, it should make sense that this distance is 1. If this distance is 1, then the ordered pair for that is write 1 and stop. So 1, 0. Again, all we're doing is finding locations, and that's just ordered pairs from pre-algebra. Okay, next, at 30 degrees. Well, at 30 degrees, here's the radii, and I'll draw that in green so we can see it, and that radius, the length of it, is 1. This angle is 30 degrees. So what I want you to notice, and you need to watch very closely, is that if I take this point, which is intersecting the circle, and I drop down a perpendicular to the x-axis, what happens is it creates a right triangle. I'm now going to highlight this triangle. So we're all looking at this one little piece. And what I'm trying to do in the next few minutes in this video is share with you the importance of knowing right triangle trig. So the last couple weeks, we've been learning sections 1 and 2 in our textbook. That dealt with right triangle trig. Today we're switching over to unit circle trig, but they're not that much different. Triangle trig is related to circle trig. You just saw me draw a right triangle in a circle, so they are connected. So if this is a 30-degree angle right here, and that's what we labeled that to be, and this is a 90-degree angle, then we know the angle at the top up here has to be 60 degrees. It has to be. And so right now we've created a special right triangle that we learned in the last section. Taking our knowledge and our understanding of a 30, 60, 90 triangle, we now know and should have learned that the ratios across from these angles are important. There's always a pattern to them. Across from 30 degrees is 1x. Across from 60 degrees is x square root of 3. And across from 90 degrees is 2x. But we already know the hypotenuse in this triangle is 1 because it's the radius of the circle. So now what we do, focus only on this triangle, is we go to the side and we take our ratio and we set it equal to 1. We're solving for x, so of course we just divide by 2. We get x equals 1/2, and so then we go back and we fill it in the right place in our triangle. So if x is 1/2, then we look for the 1x, which is here, and so this distance is going to be 1x. So I'm going to erase this. I'm sorry, 1/2, not 1x. So we're going to go here and we're going to substitute 1/2 right in there. So that's that purple distance. Now the angle or the side across from 60 degrees is x radical 3. Well, that's this yellow piece down here. And if x is 1/2, then this answer is going to be radical 3 over 2. So we'll get rid of my ratio right now. Hopefully you followed me on where I got that from. So this one is radical 3 over 2. So that means the distance from the center to this location, not to the circle, but to this location, is radical 3 over 2. The distance from this location to the circle is 1/2. I'm wanting to figure out what the ordered pair for this location is. How do I get there? Well, I get there by moving right this many and moving up this many. And so the ordered pair for a 30-degree angle on the unit circle is square root of 3 over 2, comma, 1/2. And you do need to leave it in radical form. Do not convert this to a decimal. Alright, so all that triangle stuff that I shared with you is just showing you that the right triangle trig is related to unit circle trig, and I also wanted to show you where it came from and why this answer is like it is. So our x coordinate at 30 degrees is radical 3 over 2 based on the length of this triangle, and the height is the y coordinate of this ordered pair. Alright, we're going to do that one more time for the next one. So this angle is 45 degrees. If I were to take that point, drop down a perpendicular, I would obviously create another right triangle. Okay, in that triangle, I'm going to highlight it in a different color, making sure we can all look at the same piece. It's all of this plus the green down here. So here, here, and here, all the way. Okay, that blue triangle right there has a radius of 1 because it connects the circle to the center. If this is a true 45 degree angle, let's get rid of the last one. So if this right here is 45 degrees, and that's what that says, and we already have a 90 degree angle, then we should know that this angle is also 45 degrees. And so right there shows you that that's another right triangle. And so I think this time, where I have a lot going on, I'm going to pull it to the side so we can see it better. Turn it the way it's facing in a circle. There we go. So here's my 45 degree angle. Here's my 45 degree angle. The radius is 1, and I need my ratios. Across from 45 is 1x. Same deal here. Across from 90 is x squared root of 2. I'm going to set my ratio equal, come down here, set my ratio equal to 1. And then I'm going to solve for x. When I do that, I get a fraction that has a radical on the bottom, and we know we're supposed to rationalize that. So we got to get rid of the radical off the bottom. You're going to multiply by radical 2, top and bottom. The numerator is going to be square root of 2. The denominator is going to be the square root of 4, which is 2. So this is the distance here as well as here. They're the same answer. And so if this distance is square root of 2 over 2, if this distance is the square root of 2 over 2, and this distance is the square root of 2 over 2, then the ordered pair for this location, follow my color here, that location is going to be right radical 2 over 2, up radical 2 over 2. And that's why the ordered pair at 45 degrees is square root of 2 over 2, comma, square root of 2 over 2. And again, so those patterns that show up in special right triangles exist inside the circles, and that's the reason I'm taking time and videoing this for those of you that are at home, so you understand where it came from. Again, I would make sure that I got a paper copy of all of this. It actually would have been better if you had it before the video. But either case, you need to be responsible to know all the parts. Alright, so that's the only two I'm going to share how I got there, and the rest of it we're going to continue around. At 60 degrees, I'm just going to go ahead and give you the ordered pair, but 60 degrees is related to 30 degrees, so it's the inverse of this. You're just going to switch those x and y coordinates. So 60 degrees is ordered pair is 1/2, comma, radical 3 over 2. Alright, then at 90 degrees up here, that location, super easy. I'll start at the origin. The yellow is a radius. A radius is 1. So from here to here is 0, 1. Let's go over here and do this one. This one's easy. From here to here, radius is 1. I go left 1 and I stop. So the ordered pair for 180 degrees is -1, 0. The ordered pair for 270 degrees, or 3 pi over 2, can be found by starting at the origin, going straight down 1, so 0, -1. Be careful, don't get those mixed up. That's just basic graphing points. Alright, the nice thing about the unit circle, again, there's all kinds of patterns out there, but one nice thing about it is if you do memorize the first quadrant and you understand like the x value and the y value for each of these angles, then the second, third, and fourth quadrants are super easy. There's always patterns. Get rid of all this so we can see. Okay, and here we go. Grabbing a highlighter right now. Please follow from the origin to the 30 degrees. It's 30 degrees above the x-axis. Well, in the second quadrant, this angle is also 30 degrees above the x-axis. In the third quadrant, this angle is 30 degrees below the x-axis. In the fourth quadrant, this degrees is 30 degrees below the x-axis. So everything I've highlighted in green right now, the reason I'm doing that is to share with you there is a pattern in the ordered pair. If 30 degrees is radical 3 over 2, 1/2, then all the other ones that are the same distance from the x-axis has to be a similar ordered pair. But please remember your algebra skills. We all know that the second quadrant ordered pairs are a little different than the first, because to get to the second quadrant from the origin, you must move left and up. The x values are negative, the y values are positive. So you would copy the same ordered pair down, but you would make the x value negative. So it should be negative square root of 3 over 2, and then comma, positive 1/2. For 150 degrees, that's your ordered pair. For 210 degrees, down here, we're in the third quadrant. The ordered pair for all the third quadrant locations are both negative. You have to go left and down. So negative radical 3 over 2, comma, negative 1/2. And then jump into the fourth quadrant, 330, ordered pair for that. Well, I have to go right and down, so the x value is positive. The y value is negative. Again, make sure you're copying all of these down. You're getting them in the right places as well, because the copy of the unit circle, the location of where those parentheses are sometimes can be confusing. If you're looking at the paper, you know what I'm talking about, so be super careful where you place those. Alright, next. Here's another pattern. I'm going to use blue this time. Any angle that's in the same position as 45 degrees is going to have a similar ordered pair. See how this one is in the middle? Go to the second quadrant and find the angle in the middle, which would be 135. The angle or line radii that's in the middle in the third quadrant is this one, 5 pi over 4. And the one in the fourth quadrant is this one. All the ones I've shaded in blue right now have the same ordered pair. Of course, the signs are different. So, 45 degrees is radical 2 over 2, radical 2 over 2. Then 135 is negative radical 2 over 2, comma, radical 2 over 2. Okay, jumping down here, third quadrant, the x and the y have to be both negative. So negative radical 2 over 2. Negative radical 2 over 2. Alright, next, fourth quadrant, 315 degrees is in a similar position as 45. Its ordered pair is a positive radical 2 over 2. And then negative radical 2 over 2. Alright, we've got a lot of it finished. Now we're going to go with the ones we've skipped. So let me grab a different color highlighter. Here we go. 60 degrees. That radii is in a similar position. It's close to the y-axis. So any radii that's close to the y-axis, that's a good way to think about it, have a similar ordered pair. Okay, so at 60 degrees, at 120 degrees, down here in the third quadrant, it would be 240 degrees. See how it's close to the y-axis? And 300 degrees, these, let me try that again. These have similar ordered pairs. I hope that the colors are helping. So if 60 degrees is 1/2 comma radical 3 over 2, that means over here it's going to be the same exact ordered pair, except we're in the second quadrant, so the x is negative, y is positive. Okay, let's go down here to 240. X is negative, y is negative. Okay, we're going down here to 300. Looks like the last one. We're in the fourth quadrant, so a positive x, that's going to be 1/2, and a negative y value, that's going to be negative radical 3 over 2. So when we're scanning this unit circle that has taken us a while to do, the red is the degrees, the blue are the radians, and the green are the ordered pairs. And that is the unit circle. Again, make sure you stop by the front office and get your paper copies of the unit circle and the trig table, which I'll discuss in the next video. But also check out YouTube, Khan Academy. There's all kinds of different ways, songs to help you remember these different parts.